Hi guys, welcome to Learning Electronics Repair, and I have two more amplifiers to look at here. These are Class D amplifiers. They're not the same, they're similar. So Digit 2K2, 2x1100 watt digital amplifier, Digit 3K6, 2x1800 watt. Yeah, so they're just like two different amplifiers from the same range made by this company, Synq with a Q, okay? This one is the higher rated, so we can see here, stereo into 4 ohms, 2 channels at 1800 watts each, in bridge mode into 8 ohms, 3600 watt, okay, we can see that. And then the other one doesn't actually say, but we can say this is 2200 watts, so it's a little bit lower powered, okay? These both came from the same person. I did try them, or at least power them up with the current limiter in while it was here. So I'll show you what they are doing. They have a slightly different problem between them by the looks of it, but they both have faults on them. I think he said it would trip the power out. Maybe that's what the current limiter was stopping from happening. I don't know if these are similar enough to work on them both together, or whether I have to take them in isolation from each other. But let's just get the current limiter. You can have a look and then let's see what happens. So here's the first one. Just attach the power to it. You'll see the light bulb over there. Okay, so what does it do? Well, the light bulb comes on and stays on. Whether this is switched on or off on the on-off switch here doesn't make any difference. The power light doesn't light. So let's draw in a fair bit of power. And then the other one, light bulb comes on then goes brighter, but the power light does come on. This one, limiter's on. So this one is probably powering up, and it's just that it's drawing a fair bit of power. And I have quite a low wattage light bulb. So this one, effectively, the limit light comes on and stays on. That's not protect, but it's a similar sort of thing. So let's look at the other one first, the one that doesn't power up at all. Let's see if we can get anywhere with that one. Okay, so here's a first glance inside this. What do I see? Well, this is clearly a switch mode power supply. We can see lots of devices down here. These will be the switching transistors, I would think. Whole row of them. Yeah. A transformer, which is smaller than you might think. So this thing here, this looks like a, yeah, it's like a rubber foot or something glued on top of that thing. But that actually is loose. Oh, this unplugs. That unplugs. It's some sort of power 1 amp. I think that's like a little power supply itself, like some sort of startup thing. Like a standby. Okay, because the on-off switch here just goes down here. It's not like a mains switch. So that must be a standby supply. It has a big inductor here. So we have filter capacitor, filter inductor, and then this big inductor, this is either a power factor correction PFC circuit, or it's some sort of LLC circuit for the actual power supply. We have two capacitors. We'd have to see if these were in serial or parallel basically to figure that out, but I'm going to say at the moment this might well be a PFC, and the reason I'm thinking that is because I have two big switching devices and what looks like a big diode under here. And if that's a big diode, then this is probably PFC. So two switching MOSFETs in the PFC, 4 in the main switch mode, switching this transformer. A bridge rectifier here, so that's 1 voltage output, and probably a load of diodes here, another one. And that board, yeah, this is like a separate PCB, so we can probably disconnect that and test that in isolation. Then We have another separate PCB under here with some fuses on. Okay. We'll test them. Another inductor, filter or something. And then this is just horrible. Look at this. Man. This is all covered in some real nasty stuff. And I don't think this and this module is even something you can repair. You know, look at that stuff, it's horrible. So these are probably like the pulse width modulator, basically for the Class D amplifiers. Under here will be the output devices for the 2 channels, which can either be run as right and left stereo, or they can be run as a bridge. And then, oh, I'm thinking now, you see we have another set of these filters here and here. I think this is on the output of the Class D, maybe. And then we have all these big capacitors, which I think is just filtering, basically. So I would say there's 2 different voltage rails here, one from this bridge rectifier, one from this lot here. Okay. Most likely we've got a plus and minus 15 and then a plus and minus HT, some high voltage. There could be a 3rd voltage rail giving the 15, I'm not sure. This is just a look around. Then this PCB, this is L-shaped, so the power supply PCB also goes down here. So after the bridge rectifier, we've got an inductor, another one, we've got some smoothing capacitors. There's 2 smaller ones here, but these say 160 volts, so they're quite a high voltage rail. They're all 160 volt, actually, those capacitors, and all these as well. So they're all 160 volt caps. These modules, by the way, which are just covered in something horrible, are actually removable. So these, yeah, you see these just come off. You can see underneath them. Digital amplifier 1018. It's possible you can buy a replacement module. Are they also both the same? So maybe this is like we can test by swapping them over as well. Let's have a quick look. This one's a bit harder to get out. Okay, it doesn't want to come so easily, but if we need to, we can just look. They look like they're probably the same, just one's mounted the opposite way around to the other one. Some other sort of module on here. This may well be the 15 volt supply. You see? Held down with a screw. Let's have a quick look. Yeah, this comes off as well. Okay. We can see some more capacitors under here now, some more rectifier diodes, and I suspect that on here are the voltage regulators. There's actually 3 of them for like low voltage supplies. I mean, one might be the supply to all the fans at the back, for example. So that's what that seems to be. Again, this has screws here and here. Looks like this comes off. So it's all fairly modular, I'll say that much. So let's have a quick look at the other one. And this is the 3600 watt, by the way. And here it is. So it's the same but different. Yeah. For example, we can see there's only one capacitor here. This is that little module, power supply 101A. And then we have digital amplifier 101 and another one. So these again are modules, but they're not made the same way. We have some of the capacitors. So I think they've used the same PCB for the power supply at least. It's just not so populated on this one. We still have the same number of switching devices. Yeah. So that's what we have. I think because of the way this is put together, it wouldn't be too difficult, for example, on the one which just seems to have some problem even when it's not powered up, for us to disconnect the amplifier, which is the load basically. Yeah, disconnect the amplifier part. So we just have the power supply and see whether we can fault find it if a problem it is in the power supply. Another thing I'll just mention before we start, let's have a look to see if we can find a schematic or service manual for either of these, that would help. I've done a Google search, Synq Digit 2K2 schematic. That gave me this link. So this is for the 3K6. This is Electrotanya. This is a very good site for finding schematics. And I've actually downloaded that one. We'll have a look in a minute to see if it's actually what we're looking for. Okay. I didn't see the Synq Digit 2K2. It didn't find a link on here. Only the 3K6 came up. Maybe it is out there. Maybe they are similar enough for me to be able to repair both using the same schematic. Let's have a look at the download and see what was in it. Service manual. Oh, we may have something useful. Well, we certainly have some information. Yeah, we have some schematics. Is this the same thing? Well, yes, it says Digital Amplifier 101AB, so I'm pretty sure this is a schematic that's useful to us. PSU section. Yeah. Oh, this is helpful then. So first we can see, yes, it has PFC. These are your switching devices, 4. So 2 and 4, like I thought. The big diode is probably that one. Yeah, guys, I think we might have a fighting chance of getting somewhere with this. Oh, in fact, it actually mentions here the Digit 2K2 as well as the 3K6. So it looks like this schematic will actually help us with both, and that's great. So back with this one. Let's just see. If we switch the switch off, okay, then we power it up with the light bulb. So that comes on at that sort of brightness anyway, and we know this will power up. So that one does do that. Anyway, it's drawing a fair bit of power. Let's start with the power supply then, because one of these amplifiers seems to have a problem with the power supply. The light bulb comes on bright, it doesn't start, okay? So we can see quickly power coming in, yeah, through some filters here to the bridge rectifier, 20 amp, 600 volt bridge rectifier. And after that, this is the PFC section. So we have a big inductor. We have, in this case, 2 MOSFETs, which are basically in parallel with each other. Okay, switching at high frequency. And that's a boost converter. So coming through this diode here, we have high voltage pulses and we get 380 volt here. I've made several videos, in fact one all about PFC, all you need to know about PFC to fix stuff. So I won't go into the details on this video, but I will link that in the description. If I forget, remind me, okay? So that's the PFC section, and this basically takes the incoming mains voltage, 220 volt AC, which will give us about 320 volts DC here. This voltage, okay. And that through here, 380 volts DC. So that's your PFC. Just looking here, we have a diode and a capacitor. So this is charging this capacitor. This is some sort of adjustment for the PFC. So it's monitoring the voltage here, which is before the PFC, the boost converter. It's monitoring the voltage afterwards here. And through this little bit of a network, it's generating some sort of feedback that goes into the PFC controller and alters the timing of the pulses, okay, to here. So that's basically what the PFC is doing. Coming out of here then, plus 380 volts. This is a little power supply, like a standby or something. Or, yeah, there's no transformer in, but some sort of DC to DC converter. Okay, we can see we have 380 volts coming in, LED, 16 volts going out by the looks of it. So that's some sort of converter, I would say. This is that little module that's plugged on there, power supply 101A. I'm fairly sure this is effectively a standby supply. It looks like it also maybe generates the PFC signals. Let's have a quick look. What do we have here? We have an on off, 2.55 volts on off. That's like a soft start, plus 20 volts for the PFC. So we have a few voltages coming out of here as well. Okay, then we have the main switching transistor. So there's two here in parallel. This is your high side, if you like. There's two here in parallel. It's a low side. This is low gate and high gate drive. So this is, again, is being switched alternately by the pulse width modulator controller. I'm sure we could figure out where it was if we look back. Does it come from here? LG, HG. Yeah, so it looks like this little module here is your pulse width modulator controllers, basically. You can see there. So this is high gate and low gate. That's driving the main power supply. And this is PFC gate. Yeah, so this thing is not a standby power supply like I thought. Or maybe it does incorporate that, but it's basically the pulse width modulator. Okay. If we look at this circuit, then we have the 380 volts. Yep, coming in here. Look, they're just using the net, the same name. 380 volts. So big smoothing capacitor, you can see it there. Well, 10 microfarad, 400 volts. Another capacitor here, lower value, probably 220 nanofarad, that one or something. Yeah, looks like a 2.2 microfarad, that one, 400 volts. Okay. So the 380 volt comes here. And we have the two sets of MOSFETs in series, high side and low side. This is hot ground here. We also have these two large capacitors. So you see there, 400 volt, 400 volt. And the transformer coil, one end connects between the junction of these two pairs. Okay. And then there's another, in fact, there's two inductors, inductor, inductor. The other end connects back to here between these two capacitors. So this is a half bridge circuit. This end of the transformer has been switched alternately between 380 volts and 0. Yeah, so these and these are never switched on at the same time. They switch on first those, and then they switch off and then these on, and vice versa. So that effectively keeps changing here, a square wave from 380 volts down to 0, up to 380, down to 0. That drives the transformer coil. And the other end of the coil comes to the junction of these two capacitors, which basically is a voltage divider at high frequency, a capacitive voltage divider. That end of the coil is held at 190. So that end basically doesn't change. This one switches up and down. So this circuit is called a half bridge. Okay. This little bit of circuit around here probably helps to smooth out the square wave, make it a bit more like a sine wave. This is not an LLC circuit because we have the two inductors, but we don't have a capacitor in here. Unless somebody tells me different, this is a half bridge, not half bridge LLC. Okay. If you want to know what half bridge LLC is, again, I made a video all about this on ATX power supplies, which is similar to this. I'll link it on this one. So anyway, back to our schematic. I hope you're enjoying the look around. We have various secondaries. So we have secondary here. This one, bridge rectifier, capacitor. This says 10.5 to 23 volts on these four connectors. And I'm fairly sure those go to the fans. I'll show you the connectors in a minute on the board. I think this is the fan speed control. Okay. We have this one coming from a secondary here. Okay. This is your plus and minus 15, which I said we would have. There's the voltage regulators. And then we have this one. So this is your main supply, if you like. It doesn't give a voltage on this, but plus V and minus V. Okay, plus V, minus V. Here it says 110 volts, 110. So by the time they smoothed out, they're probably more than 110. These capacitors are rated at 160, maybe 140, something like that, plus and 140 minus, okay? We also see over here a 16.5 volt supply. I think that's coming from here. So we have that as well. So we have several supplies here. Now, the problem with ours is it doesn't start up. So I think we'll make some basic checks first on the high voltage side and the low voltage side of the power supply. The owner tells me this one blows fuses or trips out the mains. So that suggests we have a short somewhere. We know it's drawing quite a bit of current from the way the light bulb limiter is acting, but that's stopping anything drastic from happening. So if it's drawing too much power and blowing fuses, that would suggest that there's a short somewhere. Where's the most likely places to have shorts on here? Well, one is on the output. So that plus V and minus V, the plus 140 volts, minus 140, whatever it is, supplies this big amplifier, and the short could be there. It could be on one of the smaller rails, but I doubt it more because they're quite low power rails. It's not so common. Or it could be shorted rectifier diodes on the output, or it could be shorted MOSFETs in the PFC, or MOSFETs in the main switch mode power supply. And the reason I'm saying these ones and these ones is just because there's two in the PFC, and the diode, which I think is this one, and there's four, so that's almost certainly what they are, until I prove myself wrong. These are those four connectors. I don't see any numbers on them, but I'm fairly sure that is that supply. We could say from 16 to 27 or whatever it was. That's the speed control for the fans, okay? I'm in ohms range at the moment. Just test the meter. Yeah, it's fine, okay. Most likely places for short circuits then. Output of this bridge rectifier. This is on the lower voltage rails. What do we have? Well, we have a resistance climbing up as a capacitor's chart. So there's no short there. There could be one derived further down. This is the plus and minus 15. It's a little bit hard to get to that at the moment. And these will be on the high voltage rail output. I would say these four, just because they're large diodes. They're probably double diodes. Each one is probably, I can see just down there. They are, in fact, down here. I think, there may be 2 pins. I can't see. So it's hard to get down there at the moment to test those. I think we would have to take the PCB off to do that, but we can check somewhere else. So these are the supplies to the amplifiers. This is your plus and minus 140-ish. So there's fuses on here, and we can see the cable coming in. So if you look here, this says plus V. The blue one says, if we just get to it, yeah, minus V. And then there's a black one which goes over that way somewhere, which says ground, so we know what we have. Okay, we can see the black, the blue, the grey, and then next to the blue and the grey there's a fuse, and the same for the other channel. So we know basically what we have here. We have plus and minus supply, and we have fuses on each one on each amplifier. So there's a fuse gone. No, the fuse is okay. Fuse is okay. Look on the other side. Fuse is okay. Fuse is okay. So I don't think there's going to be any shorts on here, otherwise a fuse would blow. Is there any short on the supply before the fuse? I doubt it, but let's see. So this is ground. This is your minus supply. Look, no, resistance is climbing up, that's fine. Capacitors are charging. This is your, in fact, this is the plus supply. Okay, and it'll be the same on these. These are connected to the same place. So these will read exactly the same. Yeah. So there's no short circuits in the obvious places on the output side. That brings us to the input side. So the most likely places again is around the power devices. We could have a short circuit diode in here, but that wouldn't blow the fuse. It would just stop the PFC from working basically, but it might blow these. Yeah. So let's have a look. I'll just prop this up at an angle so you can see. So this is the diode. I'm in resistance range, so you'd expect it just to read open. Reads open. MOSFET. Resistance climbing up into kilo ohm, so that isn't short. So these are in parallel. So if one reads short, they will both read short. Okay. So again, that one's just climbing up. It's gone open now. It's charged whatever capacitor somewhere. Okay, so you can see again resistance into the kilo ohms climbing up, and then the switching transistor. So again, we want to go to the drain and source. Oh, and that reads short. So if one of these reads short, we've got two high side. Let's go to the other one. Yeah, and then two low side if they're in that order. A bit awkward to get down this one, I'm sure I will. Short. Does this read short? Yeah. Did it read short to the gate? Oh, close enough. Ah, thought that might happen, guys, sorry. Try the other one. No, it reads like, that reads a resistance to the gate. This one, that is like short to the gate. I'm a bit concerned about that because we know all the gate drive for this comes from here. And I'm not sure that's something we can actually fix. Might be able to get one, but... This, if you look at it, looks a bit distressed. I'm worried about that thing, okay? But we definitely have some shorts here. I'll just show you that on the other amplifier so you can see what we would expect if we didn't have a problem there. You see, this doesn't look distressed like the other one. We have all the devices again. I'll just see if we get where we can look at it, okay? So with this one, if we go on any of these output devices, let's have a look. You see that doesn't read short. Okay, and we'll just go to one of these pair, I think. Again, that doesn't read short, and this is the one that powers up. So we definitely have short circuit switching transistors on that other one, at least. Could be other problems. But we need to take that PCB out now to have a look. Here's the little module. So we know this is the pulse width modulator for both the main power supply and for the PFC. They burnt. No, I think it's just something on them actually. This black stuff. This is completely sealed. There is absolutely no way you could repair this that I know of. It does look distressed compared with the other one. So if that is faulty, we're going to have to replace that. We have one of these on the other one, so maybe by measuring across some of the pins, and we know where they go to. If they read different, we know we do have a faulty one. So we have that. We can now see where that fitted, so that came from here. Okay, we can now see our main switching transistors are down here. This is the PFC diode, so you can see the first of the power devices, the second one, they're in parallel as we knew. This is the PFC diode, and these are the switching transistors. There's 4 of them. Okay, PFC diode. Let's see. That reads okay. Yeah, it's like a Schottky type diode or fast silicon rectifier. That's the reading for a fast silicon rectifier, basically. We know that these looked alright, so I see a diode there. Not there. That's the parasitic diode between the drain and source. I should see the same on this one. Yeah. Then the gate just reads open, basically. Yeah, that's gone to open now. Like a highish resistance. There's probably a gate to source resistor, actually. Yeah. Just go to ohms range. 176k. And 5k. That's probably the gate source resistor, I would think. We can check on the schematic to see what we have, but that looks okay. And then these are the problems. So that's gate to source, gate to drain. Okay. Now some of these are in parallel with each other, so they may not all be faulty. I've got to take them out anyway because we're all reading short. We can check. Although if I'm replacing them, I'll just replace all of them, okay? Can we see what they are? Oh, interesting. They've got numbers written on them, 18. Or say 18 for some reason. Must be something from the factory. I'm not quite sure why they've done that, but they've done it for some reason. But I think the main problem is this. So I'll get the one off the one that powers up, and let's see if we can determine A, is this faulty? And if it is faulty, B, can we get one? This shows the connections to the little power supply module. So this side, if we have a quick look, we can see this is the PFC controller side of it, PFC gate. This has a ground connection on pin 5 there. That says B-ground, which if we have a look, that's here. So this is what we call hot ground, okay? This connector is the one that drives the low gate and high gate for the switch mode power supply. This is where the MOSFETs have gone short. So this is the one I'm really interested in, but I'll check both. We see this as a symbol here, like a little AC signal ground. And if we look at the schematic, that is here. So the only difference between the two are this set of 0.05 ohm resistors and a 0.1 ohm all in parallel. So this is the current sensing resistors. Because the value is so low, for our multimeter effectively ground is ground. So I want to have a look comparing the good one with the bad one. And I'm going to have a look from all of the pins with reference to ground. I'm going to do it in ohms range and in diode mode. And let's see if we can see any difference between the two. You can also see that the ground here is on pins 7 and 8. That actually might be important because if we look at the modules, then we have the 10-way and the 8-way. It actually showed like there was 2 connectors in parallel, but there's actually only one. The thing is, I'm not 100% sure, looking from the board, which end is pin 1. I think it says 1 here. Okay, but we can pretty much work this out because we know that 7 and 8 are connected together, ground, and I'm sure they'll be connected on this board. We can check on the module as well, but I'm pretty sure they'll be connected together on this board. Okay, so if this is 1, this is 10, 9, this is 7 and 8. Well, if they are connected, I just can't get the meter probe down far enough. Okay, I think that's in far enough. So pins 10, 9, 7 and 8. Well, they don't connect together. Neither seem to connect together. That's interesting. Let's check on the module. So it comes from this way round. So if that says 1, this is pin 1 here. So 7 and 8. No. Yes. So those two connect together. So this is 7 and 8. So this in fact isn't 1 at all. This is 10. Okay, but we know which end it is. Look on the potentially bad one. I think the same will apply. Yeah, 7 and 8. So I'm going to measure from the 7 and 8 to each of the pins. I'll probably just put a crocodile clip lead on actually. So that's just going to the black lead on my multimeter both together. So I just need one lead now, no messing around. So pins 1 and 10 are the high gate and low gate drive. We'll start there. So high gate reads open on that. I'm in diode mode. Reads open on that one. So they're both the same. Low gate drive. That reads, well, I'm in diode mode 1.059. And this one reads basically the same. Let's look at the other ones. So we have this pin 1481. That reads different. And possibly different enough for me to suspect it. Let's look at the other pins. That reads like a diode. 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 Open. 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 They all read open on that one. I suspect all the high gate drive circuitry is effectively floating and it's got a different ground basically. So it looks sort of okay, apart from I'm a bit suspicious of this one. Yeah, 4 is not connected anyway. These are the ones that read open. That's the 20 volts DC coming in that reads different. I wouldn't like to change these if there's a problem in this, because if there is a problem in this, then it could well blow those up again. The better news, and it's going to really settle it for me, is I can actually buy these things. There's one here, Synq, that's the manufacturer, €18.74 plus some postage no doubt, but they're not like stupidly expensive, and considering the value of these amplifiers I think we should just order one. In fact, I've just spoken to the owner. It says here availability is low, stock low. He says order 2. He's got a spare one then. I think that's some more of these amplifiers, so we'll order 2 of those anyway. This is possibly okay. Yeah, it may well be actually there's a transformer at the end of this. I'm a bit concerned about, like, I'm not sure if it's just glue or if it's just like distressed. Yeah. Anyway, no worries guys, we'll just order them, yeah. Then the 4 output MOSFETs. I can get these from Mouser. I've actually shown this to the owner. I can get these from Mouser. They're like €8 each. In quantity of 1. Mouse is always €20 delivery on top to here, so you're looking at €52, or I can order them from AliExpress and they are like, well, with the shipping about €17. He actually says do this, so again at the end it says choice. Okay, so we know what we need for this, but just before we end this video and before I place the orders, I want to just check to see if there's any other issues I can spot, anything obvious with this. So we can see there are some low value resistors around here. This looks like a load of 22 ohms. I've seen some little ones as well, possibly in parallel. Let's have a quick look again at the schematic. This, by the way, is that little standby supply I was talking about. Okay. They've shaved the number off this chip, but we can see this is DY106. Yeah, IC9 is the reference, so it's a DY106 as the port. Let's see if we can spot anything that may have been damaged when these things went short. Well, the current would have flown directly through the MOSFETs to ground, which is this ground. Okay, like the little tilde symbol, I think it's called, that squiggly thing. And we know the power comes in here. So we have all these low value resistors. So it's possible a short would have caused these to go, but I don't think so because the thing is drawing quite a bit of current. I can't see how that would be, but if I can just spot them, I'll have a quick look. Yeah, I can see them here. So 7, 8, 9 and 10. There's a couple more. So 7 and 10 are there. 8 and 9 are here. On my board, we can see that 7 isn't actually fitted. Never was by the looks of it. So we have 8, 9 and 10. Okay. So see what these read. Should read very low. Yeah, it's here, like big thick tracks. So it's from across here to here, basically, where those resistors are. Should read basically 0. I'm sure they do because I say the thing is drawing power. Well, the meters, let's just see if we can 0 it. Zero. Yeah, as you'd expect. So I don't see anything else on the schematic that would really look like it should be damaged by what's happened to this. So we can order the parts for this. We basically know what we need, good chance of repairing it. And let's look at the other one on the next video, see if we can fix that one as well, or at least figure out what's wrong with it. Hope you enjoyed that, guys, and I look forward to seeing you all again soon on Learning Electronics Repair. Ciao for now.